Hello everyone, my name is Chen, and it has been such a great pleasure to share my assignment answer with all you guys. The topic I picked is understanding the solar system. But before we start, here's my student ID card. You can also find my ZID on my very first page of my slides. So here we start the very first section of the question 9. Does the planet move as the moon orbits? I would say yes. This movement is due to the gravitational interaction between the moon and the planet. And also, according to the Newton's third law of motion, every action has an equal and an opposite reaction. This means that while the moon is attracted toward the planet by the gravity, at the same time the planet is also attracted toward by the moon with an equal force. But however, the movement of each object due to this gravitational attraction depends on its own mass. So the more massive an object is, the less it moves in response to a given force. So for section B, I put my answer on my slides, and I'm going to explain it. So, um, in the Sun planet system, the Sun is actually overwhelming more massive than the planets. So, which means that the COM, the common center of mass of the system, is very close, or actually inside the Sun. This makes the Sun movement in response to the planet relatively small. And in contrast, the planet moon system, especially one where this moon is relatively massive, the COM can be significant distant from the center of the planet. And for section C asks where there are centers of mass in each scenario from question 1, 4, and 7. So I put the screenshot of 147 from left to right. So let's start from the very left side. So I would say the COM of the question 1 is very close or near to the center of the sun because the sun's mass is much greater than the Earth. So the COM is actually often within the radiance of the larger body, which is the sun. That's why we could not see the sun making a large observable motion in response to Earth. And for the second one, the middle one, they are actually the same, like pretty the same, because even we double the Earth's mass, uh, this does not make quite difference with the first one. The only difference is the COM might slightly shift from the original place. And for the question 7 is that the changing on velocity does not actually matters the COM position, but but influence the location, by influence the shape and the stability of its orbit. So for question 11, as we all know that the standard unit between the sun and earth is one astronomical unit, which we so-called 1 AU. But as you can see, there's two gradient lines away from between the star and the planet. So each gradient would represent 0.5 AU. And for question 14, I pick up I list out four different planet distance AU, and also I use the stimulator to find out their orbital period in days. The question asks us whether they follow the Kepler's third law. I would say yes. After I calculate the ratio of the planet distance and the orbital period on the right side, I put it on the right side. As you can see, these numbers are actually very close. So I would say they follow the third law of Kepler law. And here I put out list out the four screenshot of different AU. And for question 15, the fastest orbital velocity I would say is Mercury, and the lowest one is Neptune. And the reason for this one is because the distance. As the distance, because the Neptune have the farthest distance among all the planets. Um, so the weaker the gravitational force will occur on it. So for question 16, the thing I learned in this experiment, the main is how the capital law present in the solar system, like the increasing planet velocity while keeping the mass constant, result in shorter orbit period and more orbital orbits. And that's all. Thank you for listening.